Hi, welcome to the demo about temporal table joins in Apache Flink. To illustrate this interesting feature that you can leverage to perform data enrichment in streaming manner with Apache Flink, I will use Apache Kafka and two different topics. Let me maybe explain it in Docker Compose. So I have two topics. I have visits and adds. And as you can deduce from this topic, I will join both of them in order to produce a visit plus adds, in order to produce the visits with the adds enrichment information. Let's take a look at the code. So here I just have some convenience class with schemas, and as you can also see, I'm relying on both schemas for the visits with adds topic. Later on, there is the job, and the job what are the most important parts? The most important parts are these tables definitions. I'm starting by defining the visits table with all the schema and a watermark. Of course, I'm configuring it as an Apache Kafka data source, and I'm doing pretty the same thing for the adds. So watermark, schema, and Kafka configuration. Later, I'm using the temporal table function where I define a time column, which is the update time for the adds, and the key, which is the add page. I'm registering this temporal table function here as an adds lookup function, and the name already tells you what will be the purpose. So the purpose will be to join and to look for adds that are relevant to the visit page. So it's this condition, and the matching will be made regarding the event time from the visits. So I'm skipping a little bit the details from the temporal table join because I'm explaining it pretty deeply in the blog post, which is linked in the description of this video. But you must know that these two fields are pretty important to know what add to associate with each visit. Later on, so here I have another table, which is the join result of visits and adds, and later I'm declaring this as another table here and writing all the data into it. So to these visits with adds path. So let me now go to the Docker where I will start the Kafka broker. And while it's starting, I have to wait for the three topics to be created. I should have a message printed just in a few seconds. Okay, you can see that we have all the three topics created. And now I will start the console consumer on top of these visits plus adds. And I will also start console producers for the visits and for the adds topics. Now it's time to start the job. And I will now generate the visits. The first visit and the second visit. And now I will also generate the adds for the home page. And you will see that I am declaring here two different campaigns. However, at this moment, there is nothing in the visits with adds topic, simply because the watermark didn't move on, didn't advance. So with this watermark, the joins are still buffered and are not emitted. Right now I will add new adds just to move the watermark forward, and I will do the same for the visits. And after that, you should see that our two first matches are emitted and are enriched. And what you can see here is that the enrichment logic with our update versus event time always takes the most recent add that happened, the most recent add configuration that was updated before the event time. So that's for this reason you can see supermarket here and car dealer for the second add. Just let's see it. Yes, you can see that it's 18 and 20, and here we have 19 and 21 for the event and time. And that's the whole magic for the temporal table join. The good news is that you don't have anything to do. It's all greatly abstracted with this temporal table function and the table API. But you must be aware that the temporal table joins are only one of the many different strategies, data enrichment strategies, you can apply in Flink for the streaming datasets. Two other ones are a little bit simpler than this one because they rely most on the reach functions, and they are detailed in the blog post, which is linked just below in the description of this video. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.